Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to continue our discussion of rotation of graphs, but specifically a straight line. Last time, I said if you haven't done any trig, we learned how to do it using the x-intercept and the y-intercept, and we restricted our rotation to 90 degrees. Today, we are going to go a step further. But here I have to assume you already know your trig. So we can rotate either clockwise or counterclockwise through any angle whatsoever. So to show you how this is done, let's go and check a general case where I have here in my XY plane, I have a point, say in the first quadrant, so positive X, positive Y. It doesn't have to be, but just for simplicity. And I have a point somewhere here, P, that has coordinates X and Y. If I know its coordinates, then of course I know the angle that it makes with the horizontal, whose tangent is Y over X, right? And let's call this angle phi. And let's say this length is R. Okay. So basically, this is a right triangle. This is Y, this is X. Since rotation in the counterclockwise manner is positive, I'm going to assume we are rotating here through an angle theta. It's just, I mean, you don't have to draw it to scale, but just, you know, it makes sense. The length doesn't change because you are going to rotate the point. So this point would go here. Okay. So let's do it in a different color. So I'm going to use the pen, the blue pen. And I'm going to say this angle is theta. This is P prime, coordinate X prime and Y prime, which means that this height, which also has to be vertical here, is Y prime, and that is X prime. And that, of course, is the origin. So you can see the pencil versus the pen. Okay, now, I don't know, and that, of course, is still R. Do you see X bar, or X prime, I mean, I'm sorry, in this triangle is R cos this angle. Okay, think about it differently. Cos theta plus phi, the cosine is adjacent over hypotenuse. So if I multiply both sides by R, oops, I get X prime is R cos. So X prime equals R cos theta plus phi, or phi plus theta, it doesn't matter. Likewise, the Y prime is R sine theta plus phi. I hope you already learned in trig how to expand the sine and the cosine of the sum or difference of two angles. This becomes R cos theta cos phi minus R sine theta sine phi. Likewise, the sine, to expand it, you get sine theta cos phi plus cos theta sine phi. But in this triangle, cos phi is X over R, right? cos phi equals x over r. So like before, if I multiply both sides by r, I get x is r cos theta. And likewise, y is r sine theta. So really, r cos phi is x. So I get x cos theta minus y sine theta. And here I get this is x sine theta plus y cos theta. So you can see here, I know some of you may get confused, which is this minus, because later you will see rotating clockwise. Let's write it now so we can, so if this is counterclockwise, if I do the clockwise, that all the difference is that guy would be positive. And if I do clockwise, only this guy would be negative. So negative and positive, and here positive and positive for the clockwise. Don't get yourself confused. Think about having a line like that you rotate counterclockwise in the first quadrant. What happens? What happens to the x? The x gets shorter and shorter. Why? Because the x is basically the cosine. The cosine is the x over the hypotenuse, right? And the cosine of 0 is 1. So it starts big and then gets smaller and smaller until it becomes 0. So that's why we subtract. When we rotate counterclockwise, we subtract the x and we add for the y because the y gets larger and larger. This y would extend to that because, again, y is the sine. The sine starts at 0 and gets larger and larger until it becomes 1. But some people will say, so which one is the negative and which one is which term? The easiest way to remember it is that when you go from counterclockwise to clockwise, change the sign of the sign. Nice, right? Playing with words. So this sign term is negative, I make it positive. This sign was positive, I make it negative. It's as simple as that. Okay? Instead of redo all what I did, or you just draw a line and see that the x gets smaller and the y gets bigger, and you change the sign of the term that has the sign of theta, not the other one. The other one always stays positive. The cosine always is positive. Just the sign gets smaller. Okay, so let's see how we do it so again, the tedious way, but I have to show it to you, is that any straight line can be fully defined using 2 points. So I'm going to pick 2 points on a line, rotate each point, and then connect them and create a new line and see if it's working, right? And you say, that's too much. Yes, it is. So we are going to play, or to make a small thing here that would make the problem easy, which is I'm going to pick a line, but not any line, the parent line, meaning y equals x. Why? Because if I take y equals x, of course I didn't draw it to scale, but if it's y equals x, it means this angle is pi over 4 or 45 degrees. So now I don't have to worry about this point. It will never change when I rotate about the origin. So I only need 1 point just to reduce work, right? And time. So let's say rotate y equals x 30 degrees, and let's make it clockwise, meaning I want you to show me the equation of the line coming here saying this angle is pi over 6 or 30 degrees. Okay, I know that cos 30 is root 3 over 2, and sine 30 is 1/2. Both of them have a 2 in the denominator. So I'm going to pick a point whose coordinates is even, so that when I multiply it by the cos or the sine, I end up with no fractions, right? So let's pick an easy one. Let's pick 2 and 2 and see where my point x bar would go. So x bar would be x, which is 2, cos 30, which is root 3 over 2, so it's root 3. Plus, because I'm rotating clockwise, plus y, which is 2 times 1/2, so plus 1. That's it. And y prime equals negative 1/2 plus root 3. Oh, I'm sorry, negative 1. We multiplied by 2. I picked this so I don't end up with fractions, plus root 3. So, or you can write it root 3 minus 1. Okay. So now I have 2 points, the origin, because it's always on the line, and another point, which is root 3 plus 1 root. So we can write y equals mx plus b, but the b is 0. What is the slope? Y equals mx. So y equals, and what is the slope? Y over x, right? So it's root 3 minus 1 over root 3 plus 1. See how simple we can create the new line. So let's see the slope of this line. What is that? Okay, second inverse tan, let me open another parentheses, because here I'm going to say square root of 3 minus 1 divided by square root of 3 plus 1, close. Oh, I'm sorry, the mode. Oh, I have radian. I should have checked that. I want to do degrees, or else I would have used, yeah, so let's make that degree. Quit. Let's redo it. Sure enough, 15 degrees. Yes, that was 45, and I turned 30 clockwise, so that leaves that with 15 degrees. And you would say, but this is nice because it passes through the origin. If it didn't pass through the origin, you have to take another point and redo that, and then construct the equation of a line, knowing 2 points on it, y2 minus y1 over y, x2 minus x1 equals y minus x1 or x2 over x minus y minus y1 over x minus x1, for example. That's too much. Yes. So that's why instead of rotating 2 points, I'm going to look at the x and y coordinates and rotate them instead. But when I do that, I have to rotate them counterclockwise. Think with me. If this is the line I have, and this is my x and y, if I rotate the x and y 30 degrees, then the angle between my line and the x would be 15, right? So I do backwards. But notice here, I'm not taking a point by itself. I'm taking the equation y equals x and replace it by rotating counterclockwise. Let's see, what does that mean? I'm going to say that instead of writing y equals x, I'm going to replace the y with this. X sine theta, which is sine 31/2. So I'm going to write 1/2 x plus root 3 over 2 y equals And then when I go to the x, I'm going to use a negative because I'm going to rotate it counterclockwise. The problem says clockwise, so I'm going to rotate the axis counterclockwise. So that would be x cos theta minus 1/2 y. And I'm done. So now I'm going to move the y to the left-hand side. Notice, forget about the 2. I'm going to multiply both sides by 2. So the 2 cancels all the 2's. I'm going to move the y's to the left, so I get root 3 plus 1y, right? Because that would be positive y when it comes here. And that would be negative 1 equals root 3 minus 1x. Guess what? It's exactly what we had. Because if I want y, I'm going to divide this both sides by root 3 plus 1. Oh, I'm sorry. This is minus x, which is the same equation, but it's much faster. I didn't have to do 2 points every time. I'm just going to substitute in my equation. Let's take another example, but just do it this way and see. Let's say, let's write an equation. For example, 3x minus 4y equals 6. I want to say rotate uh, 45 degrees counterclockwise. Okay, now I don't need to do what I'm going to do. It's just as a check. Okay, meaning when if I move the 4y to the other side and bring the 6 to this side, I get 3x minus 6, and then I'm going to divide by 4. So I get y equals 3/4 x minus 3/2. Why am I doing that? To find the angle that this line makes with the horizontal. So I'm going to say inverse tan 0.75 or 3/4. This angle theta is 36.87 degrees. If I'm going to rotate it counterclockwise, it would increase by 45. So if we call that theta 1, theta 2 should be 87 degrees. Let's rotate this and see. Notice, here we are going to rotate the whole equation clockwise, meaning my x prime would be x cos theta plus y sine theta, and my y prime would be negative x sine theta plus y cos theta. 45 degrees, it doesn't matter. The sine and the cosine, both of them are root 3/2. So 3 times x. So instead of x, I'm going to use x prime, which is root 2/2x plus I keep saying 3 from last time. Okay, that's the 3x. It becomes that. Minus 4y. But what is the y? The y is negative x sine, so negative root 2/2x plus root 2/2 y equals 6. Okay, now I can multiply the whole equation by 2 to get rid of the denominator. So this goes away, this goes away, this goes away, this goes away. That becomes 12. and then expand. 3 root 2x plus 3 root 2y, negative times negative is positive 4 root 2x, negative, so minus 4 root 2y equals 12. Now, let's rearrange them so that I can find the slope. You don't need to. So you can simply say 7 root 2x minus root 2y equals 12. And that's the end of the story. It didn't take 2 minutes, right? But I want to write it in terms of y on the left and x on the right, so I can look and check to see if that slope is correct. So I'm going to leave the left as 7 root 2y. Oh, I'm sorry. It's negative root 2y. 3 minus 4. So it's negative root 2y. If I move the x to the right-hand side, I have equals negative 7 root 2x plus 12. I can divide by negative root 2, so this would be y equals 7x minus 12 over root 2, or minus 6 root 2, right? Now, let's take the inverse tan of 7 and see what angle that is. Guess what? 81, 87. So you see that you can do it much faster if you rotate the axes instead of notice that if I want to do that like I did in the other video, if I want to rotate a parabola or an ellipse or hyperbola, oh my God, I cannot just even take only 2 points if I'm doing it with points. Here for a straight line, I need 2 points, but for a parabola, I need more than that, right? Or an ellipse or any curved thing. So that should be the easiest way. Just keep in mind that we are not rotating points, we are rotating the whole equation. And for that, if they ask me to rotate clockwise, I use the counterclockwise equations. And if they say rotate counterclockwise, I use the clockwise equation. I hope that was easy for you to to understand. And again, as usual, if you have any questions, please let me know by giving me a comment, and I will try to get back to you as soon as I can. Otherwise, I hope to see you soon. Best of luck. Goodbye.